All right, let's jump right into this explainer. Today, we're talking about a massive paradigm shift in enterprise AI. We are moving way, way beyond basic prompt engineering. What we're really talking about here is systems engineering, treating the context window of an AI model like a dynamic, high-performance runtime memory space, very similar to RAM or cache tiers in a computer. If you're building autonomous agents for real workflows, their performance, latency, and reliability literally live or die by this context architecture.
Now, the crucial point of this entire architecture is captured in this one brilliant insight. An agent should never, ever take action based solely on one static prompt or a single isolated event. Think about a raw trigger, something like a workflow delayed notification. On its own, it's just a pulse. It lacks any real meaning. Context is the translation layer. It's the OS-level state that transforms a blind trigger into a highly informed decision.
So, to map out this translation layer, we're going to build this system blueprint step by step. We'll cover the context bottleneck, the anatomical stack, dynamic memory, tool loops, and finally, governance and cost guardrails. Let's kick things off with Section 1, the concept bottleneck. Why exactly do simple prompts fail in enterprise workflows? Well, imagine a simple event pops up, like a payment failed alert. A fragile agent reacts blindly. It just fires off, often suffering from that classic lost in the middle phenomenon, where its attention completely dilutes over a massive static prompt. But a reliable, production-grade agent? It pauses. It evaluates the active workflow state, pulls in user session data, and checks the overarching business rules before it makes a single move.
To build that reliable system, your architecture has to force the agent through a strict checklist. What actually happened? Where are we currently in the workflow? What specific business rule applies right now? Is there related knowledge we need to retrieve? What tools are we even allowed to use? Is confidence high enough, or does this require human approval? Look, if you just throw a million-token context window at the problem without dynamically answering these questions, your workflow is going to collapse, and it's going to take your API budget down with it.
Moving on to Part 2, the anatomical context stack. This is the macro-architectural flow.
This is how we structure the stack to prevent that attention dilution. It's a 6-step life cycle for a single event flowing through a rigid titanium-clad context chassis. We start with inputs and triggers, but we don't jump to action. Instead, we flow into context enrichment, managed by an agent orchestrator that's constantly syncing with knowledge and memory tiers. Only when that state is perfectly aligned do we unlock tool access, and finally hit the actions.
What's super interesting here is how cleanly this maps to a traditional computer operating system. Inputs, those are your raw network signals. Enrichment is your active working memory. The orchestrator is literally your CPU, planning, reasoning, handling escalation. And memory, that's your hard drive, serving up deep RAG knowledge exactly when the business rule calls for it.
Which brings us nicely to Section 3, Dynamic Memory and State, focusing on active runtime context orchestration.
So, what is context enrichment? It's defined as the dynamic process of injecting workflow state, session data, business rules, and policy context into an agent's memory right before execution. The absolute keyword here is dynamic. We aren't talking about a massive static text dump. This is an active programmatic runtime process using context pruning to evict obsolete turns, supplying the exact right parameters without breaking the conversational flow.
To get that precision, you need specific, tiered memory systems. We're talking selective RAG and vector databases for just-in-time domain knowledge. But you also need short-term episodic memory to track the immediate session state, alongside long-term semantic memory. This is how you balance context density with attention precision, giving the agent exactly what it needs to reason and nothing more.
All right, Part 4, Tool Loops and Execution. Let's talk about orchestration and context garbage collection.
The agent orchestrator doesn't just blindly fire off an API call. It runs a tight loop. Think react or plan and execute paradigms. Step 1, plan the execution based on that enriched context. Step 2, reason through the workflow. Step 3 is absolutely crucial, perform confidence checks. Does the agent actually have enough context to know this action is safe? And Step 4, make escalation decisions. If confidence is low, kick it up for human approval.
Once confident, tool access is granted, but strictly through secure channels like MCP, registries, and agent gateways. But here's the systems engineering kicker. When those tools return, say, a massive 5,000-line JSON payload, you have to execute context garbage collection. You literally have to sanitize and prune that raw payload so the agent stays focused for the next loop without blooming its context window.
Finally, Section 5, Governance and Cost Guardrails. This is all about building deterministic engineering systems.
Look, you absolutely cannot put an agent into production without these strict guardrails. You need to force deterministic outputs from inherently probabilistic models. We're talking audit logs, tracing execution paths to see exactly why an action was taken, PII detection, and context injection security to protect memory from untrusted retrieval data. Plus, you need continuous model evaluation so your agent's logic doesn't drift over time.
And then there's the cost aspect. Running these dynamic loops gets expensive fast. You have to implement cost optimization layers like semantic caching and intelligent model routing. Honestly, leveraging KV cache optimization can drop your API latency by over 80%. Add prompt compression and strict token budgeting, and that is how you keep your system sustainable and your bills from skyrocketing. So here's the bottom line. Without context engineering, agents are fragile. They hallucinate under pressure because they lack state, and they will fail in your real business workflows. But with the right context architecture, treating it as a dynamic, high-performance OS layer, agents become reliable, safe, and incredibly powerful in the enterprise.
I want to leave you with this to chew on for your own architecture. Are you still relying on fragile, single-turn prompts, or are you ready to step up and engineer a true, dynamic context operating system? Thanks for hanging out with me for this explainer. I really hope this totally changes how you approach your next agentic workflow. See you next time.